All right, this is lesson 5.3, bisectors in triangles. You will be able to identify properties of perpendicular bisectors and angle bisectors after this lesson. We'll do a quick review and vocab so you can learn some new words that are important to this lesson. Go ahead and try and fill in your answers, and you can check back. All right, we're going to use this concurrency of perpendicular bisectors theorem. As you saw yesterday when we did the triangle folding experiment, we found that the perpendicular bisector and the sides of the triangle are concurrent at a point equidistant from the vertices. So the perpendicular bisectors, if you look closely here, this point right here is equidistant from A, B, and C. So those three lines are congruent. Okay, and that point of concurrency of the perpendicular bisector is called the circumcenter. The reason it's called the circumcenter is because if we take that point and we use the distance to one of the vertices and draw a circle, it perfectly circumscribes that circle. All right. So the circumcenter of a triangle can be inside, on, or outside of a triangle, depending on what kind of triangle it is. We'll find out more about that. And the way you find the circumcenter of a triangle, well, one way you could do it is by using a coordinate grid, which is what I'll use here. So we want to find the center of the circle that you can circumscribe about a triangle, and that is the circumcenter. And the way we're going to find that is by finding the perpendicular bisectors of the three sides. All right, you might want some graph paper for this, but so if we use these points as vertices of a triangle. So point 0,4 is right there, point 0,0, the origin, and point 8,0. And if we connect those points with lines, segments, to make a triangle, now we want to find the point of concurrency of the perpendicular bisectors of the sides. So what I'm going to do is find the midpoint of each of the sides. The midpoint of this side is right here. So that's 4. And I can just draw a vertical line because the perpendicular bisector of that horizontal line will be a vertical line right there. There's one. I'll change that to a dotted line. Like that. All right. And so there's my dotted line that represents the perpendicular bisector. Notice that this distance here is the same as this distance here. All right. And I'm going to clone that and make the perpendicular bisector of the vertical line side. This is AB, and then this is C, so side AB. I need a horizontal line for that one. And the midpoint of that side AB is 2, so there's that one. And there's one more line. We kind of know that there's one point of concurrency, so I really could stop here and say that this is the point. But just to show you, the perpendicular bisector of side AC, you can probably see that this is equidistant right now. So this line and that line is the same. So if I could just come up with a line that's perpendicular to that, and to do that, I'm going to use the slope. The slope of this line is -4/8 or -1/2. So the slope of the line perpendicular to that would be the opposite reciprocal, which is 2/1. So if I go up 2/1, put that line in there, that would be the perpendicular bisector. And that looks like that. Some of you are probably thinking, well, that doesn't look perpendicular, but our scale kind of affected that a little bit. We know it's perpendicular because the slopes are opposite reciprocals. So there is the graph of showing the point of concurrency. Now, one thing that would be interesting to see here is that, and we really shouldn't use a graph that has perfectly square scale, but if I took a compass and drew a circle around, you would find that the center of that circle perfectly circumscribes that triangle. All right. So, the way you're going to find this is by graphing the points, 7 and 7 and 3. Drawing in those lines. Finding the perpendicular bisectors. One will be vertical, one will be horizontal. And halfway between those top two points, point A, point B, perpendicular bisector segment AB, that line, perpendicular bisector of BC is that line. And if I wanted to do one more, I would need the slope of this one. This slope is -1/2. You see that there, so I would need to have a slope of 2/1, which would put me points here, here, here. And so that perpendicular bisector is right there. And there's the point of concurrence. All right, so fill in our answers here. All right, a civil engineer wants to install a cell phone tower that is equidistant from the mall, the airport, the subway. How should the civil engineer determine where to build the tower? So it needs to be someplace that's the same distance from all three of these. All right, to do that, we are going to find the circumcenter, which is the point that is common to all of the perpendicular bisectors of the triangle formed by using the mall, airport, subway as the vertices. So I'm going to copy that, put it on another page. I'm going to draw in the triangle. I'm going to use some tools to help with this. So that I can find the perpendicular bisectors of the sides. find that, I'm going to draw this line here, here, and also over here. My compass. There. There. I'm going to draw a line that goes. And this is what it looks like when you're done doing the three perpendicular bisectors. So that point is the point of concurrency. So that, if I were to draw a line to each of these three vertices, those lines would be distant. And as long as I have my compass here, I'll just show you one more thing. If I squeeze it together to the point where it's the distance to one of those vertices, and swing that around, check it out, that circle circumscribes that triangle. Alright, so go ahead and try it here. I'm going to pause it and I'll begin. Alright, another theorem. The bisectors of the angles of the triangle are congruent at a point equidistant from the sides of the triangle. So in this case, Px is equal to Py is equal to P. Okay, some new words here. If we find this point and it's equal distance to the sides, that means we can inscribe a circle inside the triangle. So we're going to use these words here. The point of concurrency of the angle bisectors of the triangle is the incenter. And that kind of makes sense because it makes the center of a circle inside. The point of concurrency of the angle bisector of the triangle is always inside. And the circle is inscribed. Triangle ABC. So, when this happens, when we have the incenter, we get a point that is equidistant from the sides, not from the vertices like the last one. So to use that, knowing that those are equal, we can see from this diagram that these will all be equal. So we get GF is equal to B equal to GB. And we're trying to find GF, but we're given GB and GB, which are all the same, so we can say that 5x plus 8, substitute that for GB, is equal to 8x minus 7. Then we can use the properties of equality, maybe subtract 3x from both sides, so we get 5x minus 7 equals 8. Add 7 to both sides, we get 5x equals 15, and x equals 3. Now we're looking for GF, but that's equal to GB, and GB is 8x minus 7, so we can substitute 3, we get 8 times 3. Oops, I did a little mistake here, sorry about that. That should be 3x, that should be 5. So 8 times 5 minus 7 is equal to 33. All right, go ahead and try that. Remember that the incenter is equidistant from the sides.